Assalamu alaikum. Hello everyone. This is our fourth class in CS224 and today's goals are going to be how to have a user input in Mars, how to write an if statement, how to create an array, how to create a loop, how to store and load values from arrays. So let's get started. Alright, so basically we're going to learn how to have an input from the user, and the first of all is I made a I made a I made an input, or let's say I made a label that's called input, and it contains insert a number. And as we know, load address the address of input into A0 and let V0 have 4. It's gonna end up printing print input message, which means it's gonna print insert number, as you know, and here is the result: insert a number. So basically, it we now need to take a number from the user. So how are we gonna do this? It is so simple. It's not gonna even take more than 2 lines. Load immediate v05 syscall, boom. So this is basically user's input. As you can see here, if you go to help, syscalls, when v0 is equal to 5, it reads an integer. So there are more than one way to have an input, right? So first of all, for integer, it's for 5. For floats, it's like v0 should have 6. If you want to read a double, or to have an input as a double, v0 should store 7. And how about string? v0 should be 8, and a0 should have the address of input, and a1 is like maximum number of character to read. I'm not very knowledgeable about these stuff, so you maybe can go to the Emil, Pilta Emil, that I Emil, yeah, I think his name was Emil. The You can visit Emil, the guy who made like 38 videos and put it in one playlist. I'm pretty sure he might have covered it. He might have covered it. But like for now, our concern is how to have an input um, for a number, for an integer basically. So basically now, when I have done this code, it's just gonna have like user's input as an integer. So basically when you write load immediate v05, the system will be waiting for an input from the user as a number. So let's see now. So I'm going to go step by step. After this is called, the message is going to be printed. Insert a number. You know what? I would rather having it like this way. Yeah, that's better. Okay, cool. Let's go one more step, one more time. Clear the messages. Cool, let's go. 1, 2, 3, 4, syscall, insert a number. And now, after this syscall, there will be a cursor that blinks over here, and it will be waiting for us to enter a number. So let's say it's going to be 10. As you can see, v0 is 5 because we load, like as you can see here, we load immediate 5 to 0, load 5 to v0, so v0 now is 5. After I press this button, v0 is going to contain 10. Boom. Oops. Okay, so there was a mistake because the program glitched, but it should be working. Let's do it one more time. Okay, after this is cool. Yeah, the program is it work. Yep, it worked. v0 a, and this a stands for 10, but a is in hexadecimal, 10 is in decimal. So basically now we're done. I think you're done. Yep, you press this button, program is finished, running, dropped off button. Cool. And this is how to have an integer input from the user. Now we are done with user input. Next, we're gonna see how to make an if statement. So all I have done right now is I just changed input to quest, and quest for my point of view stands for question, and it actually asks a question: do you want to create an array? So all I have done is I just printed it's gonna be printed in the CMD, and then I'm going to ask another question. I'm going to print another string which says enter one for yes, anything else for no. and as you can see, it's gonna print here. And finally, we're gonna wait for an input from the user. So let's start. Yep. Do you want to create an array? It's printed. As you can see here, there is /n, and this is like for a new line. So this new string is going to be printed in the next line, as you can see here. Enter 1 for yes, anything else for no. So basically, it's going to take an input, but nothing is going to happen because this is the end of the code. And here where the concept of if condition comes. So let's go together. So now, if the input I put to v0 is going to be 1, I'm going to create an array, logically. If it's 0 or any number than 1, we're gonna end the program. So let me first write the ending of a program, and this is very important. So I made a label, I'm gonna call it end, and this is basically going to have load immediate v010 syscall, and this is also another syscall. This is also another syscall code, and it's very important. You must, like, this is very crucial. As soon as you finish writing your main program or like your main function, you need to have this at the end of it. Why? Basically, this terminates the program. If you didn't do so, if you didn't write this, no, I mean, like, if you didn't, let's say it's not, it's like, let's say this code doesn't exist, and now you have a function here, and let's call it create array. Cool. So basically, as soon as this load immediate v0 happens, 5, load immediate v0 5 happens, and let's say we entered 1, it's going, and let's say this part of code is not here, like, okay, we deleted, and let's say you want to finish your code here, like, we want to finish code here, like, let's say you wish you want to finish it. What's actually going to happen after this line of code being executed, we're gonna start like tracing the next code, which, let's say they're here, you know, like I'm writing some weird stuff as like if they're code, and then another function, and then another code and stuff. So it's just gonna go and keep going till the last line of code. And let's say like it's a function and it does something, it's not the end of the program. So basically you will be like, how do I terminate the program without having any problems? So basically you just need, in order to terminate a program, you need to reach this line of code, which is load immediate v010 syscall. So let's say it's very important. It's not like let's say, it is very important. As soon as you have a main function, you need to have something that finishes the function, which is the main function. And basically it is load immediate v010, and this just terminates the program. And what's unique about this, it's like the next code or like the following codes won't be running anymore as soon as you reach this line. So basically it's very important line. So yes, as I said earlier, let's go back. Let's say have end label, right? Because if statement means you're gonna do this or you're gonna do that. And as you can see here, we're either gonna create an array or anything else. And let's say anything else means we're gonna finish the program, which is like here I had a label called end, and inside it load immediate v010 syscall, and this means terminates the program. And because this is the end of the function, as I said earlier, I like to do this comment, many dashes, and then finish it with a final comment that doesn't go away from the following point of view. Okay, so basically we take the input from the user here, right? So now I'm going to like here should, like, after I take the input from the user, I'm going to have the if statement, which is also known as branch equal or branch not equal. Let me take you to another page. Okay, back. So basically we have two codes. Yeah, there are two codes, two lines of codes. One of them is branch equal and one of them is branch not equal. So basically it takes a register 1 and it takes a register 2 and it compare them. If let's say t0, if t0 is equal to t1, like let's say t1 has 10 inside it and t0 has 10 inside it, if they're both, and as you can see 10 is literally equal to 10, so basically this means jump to the following thing, which is PC counter, which is program counter will change from program counter to, and then you're gonna plus 4, then branch address, and branch address here is label, is the label that you want to jump to, right? And then multiply it by 4. This is for branch equal. Branch not equal is gonna check if the first register is not equal to the second register, and let's say also it's t0, but instead of like equal now, let me do it in another color so you can differentiate. I'm gonna make it in yellow. Not equal. Oh my god, it's so hard to see. Let me change it. How about pink? Or I think, is that pink? Magenta, whatever. Okay, not equal. Okay, that's a good color. If 10 is not equal to 10, which means okay, if 10 is not equal to 10, well, 10 is equal to 10, right? So basically we won't jump to the following label, we will just skip it, which means, like, let's say there is a code here and there is a code here, right? We go in this code, we finish this code, we go to branch not equal. Does t0 not equal to t1? Actually, t0 is equal to 10 and t1 is equal to 10. 10 is equal to 10, so they're equal. So but the code says branch not equal. So basically we just skip this branch and we don't take the label. Let's say this label is written here in this part of the code, and like, let's say it's written here in this part of the code, right? So basically we don't jump here with a green color. We don't jump here, we just keep it as we didn't see it, and we continue coding the next lines till we reach it, maybe it's upstairs, like maybe it's up here, like instead of going down we go here, maybe it's here, so we just don't take it because they're not equal. So these are codes, and now we have pseudo codes, and they're also branch less than, branch greater than, branch less than or equal, branch greater than or equal. And I think you understand what are these stands for, right? First register less than, second register for branch less than, and so on. Like, it is very basic, it's very easy. Like, I'm pretty sure you guys got the concept. Now let's apply it into Mars. So as you can see here, I take the input uh, from v0, sorry, from this line of code, and if it's 1, we're just basically gonna jump to create an array, right? If it's not 1, we're just gonna skip this line of code, which is gonna be here, and we're just gonna finish the program. So let's see. Branch equal. Yes, branch if equal, right? And then we have 3 ways to do it. Either we compare a register with a register, or we compare a register with a number. And basically I'm just gonna take this one, which is compare a register with a number. It's way easy, right? V0 1, and then create array. And this means, oh my god, that's too long, so the code is too long, so I'm gonna make sure to shift all my comments because I love to keep my comments neat. If v0 equals 1, jump to create array. So basically, after we put an input in v0, and let's say my input is v1, right? v1, sorry. Let's say my input is 1, right? So basically v0 will have 1 in it, and now I'm gonna compare v0, which contains 1, with 1. Branch equal, so 1 is equal to 1, and because they're equal, we're just gonna jump to create array function. Oh yeah, there are many lines of code I wrote here as an example, so I'm gonna delete them now. Let's say if this happens or not. It happens at line 17, so basically I'm gonna go here. Where is line 17? Yeah, as you can see, line 17 here. So I'm gonna put a check here, and then I'm gonna run the program. So as soon as we do everything in these codes, we will stop at this line, and now we can trace the code so to understand how it works. Okay, cool. Do you want to create an array? Enter 1 for yes, anything else for no. Let's put 1. Okay, and then press enter. Okay, now we stopped here. It's gonna check. v0 contains 1. So basically, because there contain 1 and the code says branch equal, which means v0 is equal to v0 to 1, we're just gonna jump to create an array. But unfortunately, there is no code in create an array yet, so there is nothing to be shown. Yeah, there is nothing to be shown. Yep, as you can see, the program terminated, but we jumped from this. Okay, now let's see what will happen. What will happen if we put 2? Okay, for example, 2. Okay, do I have the check? I didn't have the check. I don't have the check. Wait, let me put it again. It's here. 2. Okay, let's do it one more time. But put the check before you run the program, and then now run. 2. It stopped here. Boom. Now it's gonna go to 20. As you can see, 20 to 20. It says cool. The program is finished. Everything is fine. Now, what if you didn't want to check for any check and you just wanted to start a function? Like, let's say you start your program in C++ and you have a function that says create array, and you don't want anything except like as soon as you run the program, you execute the function of create an array. So basically, I'm just gonna comment this right now. We don't need it, and I'm just gonna write jump and link create array, and this means jump and save the place we jumped from. What does that mean? So this is called jump and link. It means we jump to create an array and we link the place we jumped from. So the place we jumped from is in line 19. When you execute the program and you go to line 19, you will notice that the address of line 19 is 004000028. So basically, we will save not this location. We will save actually the next location, which is the next location that contains code, which is this one. Because as soon as we finish our program, which is create array, and we want to go back to the place we jumped from, we can continue from the next line of jump and link. So basically here, this is what you write in order to jump to a function. Let's say we wrote a bunch of codes. I'm gonna put like some what do you call these comments, and then yeah, these comments, like imagine that they're codes. Like this is how we create an array. Like we didn't start to create array yet, but like just imagine that these are like how to create an array. And now we just want to go back to the place we jumped from. You just write jump to register and then RA. Remember when I told you these are going to be so useful? And basically RA is called return address. So jump and link, we jump to this place and we link it by saving the address of the following code, which is here, to register RA. As you can see, it's in 31. So basically this 31 will contain the following line 20 and 22. Oh yeah, because okay, now 22. Where's 22? So it will store this address. So as soon as we finish coding all of these and we write jump register RA at the end of create array function, we're just gonna jump back to this line. Let's test it. Let's test it. Cool. So execute and then jump and link, run the program. Let's say it's 1 because we want to jump, right? Cool. Oh wait, we don't need. Okay, jump and link means just access the following function, so we don't care about if it's 1 or not. 1 was because of how if condition works. Uh, yeah, and that reminds me, we are we are finally done with if statements. Wait, let me put in another color. Cool. Okay, going back here, jump and link create array. As soon as you press this run one step at a time, you will see that register address saving another address. Boom. Register address save 004002C, which is literally the same as the following line of jump and link here, which is in line 22, 004002C. So basically, as soon as we access jump register RA, which means jump to register RA and RA contain this address, we will jump back to this line. Wanna see? We press run one step at a time, boom. And now it's done because load immediate v010. It means we're gonna terminate the program. So you run this, program is finished, and we don't do this anymore because, yeah, as I said earlier, load immediate v010 finishes the program. So now it's time to create an array. Yep, it's time to create an array. And how to create array? Basically, in order to keep the program short, I'm just gonna delete these lines. I don't need to ask the user if you want to create array or not. Let's basically just start with creating array. So basically jump a link, I'm gonna put it here. And now as soon as I enter, I don't need the useful anymore. As soon as I enter, I'm just gonna create an array, and we will jump here to this function basically. And because jump register array means we're jumping back to the main, this can be also mean this is the end of the function. So basically there are two ways to create an array in MIPS. One of them is going to be this way. The second way is also, as we usually know, we're gonna use syscall. At this point I'm pretty sure you guys got bored of using syscall, but it is just how it is, it's like implemented functions and it has rules. So yep, let's start explaining the first way. So basically you save, as I said earlier, you put the array in data and then you write dot space, and dot space means allocate memory. Okay, and 80 here means 20 elements. So let me write something and come back to you guys. Alright, so basically these 80 are bytes, so you allocate space for 80 bytes. And as we said earlier, 4 bytes is equal to 1 word, and 80 bytes is equal to 20 words. So basically, you need to, that's also a hint for the future as well. When you're allocating space for linked list, yes, I'm saying linked list or array, make sure that they are like all of them, all of the bytes that you're allocating are divisible by 4, because this is how it works in MIPS, sorry, in assembly language, and especially in Mars, like they should be always divisible by 4. So let's say I want to have 10 elements, I'm just gonna multiply it by 4 bytes, and now I'm just gonna allocate 40 bytes. I hope it's clear. Okay, next, first of all, you're gonna load immediate how many bytes you want to allocate for your array to A0, and 80 bytes, and we said also create an array of 20 elements because 80 divided by 4 is basically 20. And then you just need to load 9 to v0 and call syscall, and now you just allocated an array and it starts in v0. So basically your array is going to be in v0. Cool, I hope it's clear and easy. So all I have done so far is I'm jumping to create array. So basically we're starting our code from here, and then we jump to create array. It's gonna ask for the size of the array, and let's say it's gonna be, let's say for example 5 elements, right? So what I should be giving to the size, I should be giving 5 times 4 20, right? But oh wait, sorry, this is not how to do it. Okay, this is not how to do it, my bad. How you give an input to the user, load immediate, how to let the user give an input, v05 syscall, right? Yep, sometimes I make mistakes, sorry about this. So basically users input, and let's say I want 10 elements, so I should either be giving 40 or 10. But because I am the programmer, I understand how it works. I understand how many elements I want. And I want 10 elements. So basically, I'm just going to give V0 40. No, sorry. Uh, I'm just going to write 10 elements, right? So now I have 10 elements, but remember, they should be divisible by 4. So I need to multiply this 10 to 4. Yes, so basically I'm putting 10 and then I'm multiplying the 10 by 4. So V0 is going to contain the 10, right? So now we need to multiply, and multiply is actually so easy. You just write MUL and pick whatever you want. I'm just going to pick the first one, mul, and then you have, wait, there is multiplies, but yes. So basically this is the original multiplication, and you must know it because it might come, it is very crucial to note. It might come in the midterm, might come in the final. You need to understand. So basically, all you're gonna do is you're gonna. Oh, wait, can I multiply? Oh, you cannot. Okay, cool. So basically, this means you're gonna multiply two registers, and the answer is going to be going to either low or high registers here. As you can see, they're not numbered, and I told you like we were gonna use them in the future. Um, so now let's load immediate. Let's say I'm gonna use load immediate, and let's say I'm gonna use t0 because it's a temporary register, and I'm gonna give it 4. Why? Because I want to multiply by 4. Oops. Yep. Um, t0 equal 4. Cool. And then multiply mult t0 and v0 because here is the number of elements we want. Let's say, yeah, v0, and this means t0 times v0, and I believe it's gonna go to high, it's gonna go to low. I believe. Let's see. Let's see. Just let me. Okay, cool. Let's see. So we execute it. Oops, we execute it, and then we go to line 24. We run the program. Size of the array set is gonna be 10. Okay, as you can see, high and low are not like they're 0 at the moment. As soon as I press this button, I'm pretty sure it's gonna be low. Yep. So now it's 28. 28 is 40 in decimal, 28 in hexadecimal, and it's 40 in decimal, in decimal number, right? So when you use mult, the answer goes to low. Make sure you know this because it's very important. You might face it in quizzes or anything. So just make sure that you know when you see mult, it just go here. Why we don't use mul and then we just write? Let's say that we have the variable in a0. So this means basically, this means multiply t0 with v0 and put it in a0, right? But actually, when you execute it, you go to line 24. Where's line 24? Yep, it's over here. But it doesn't use low. So basically, your answer is going to be in A0. But it's also good to know that mult uh, contains the value of multiplication here. If it's division, your answer is going to be in low and your remainder is going to be in high. Just to let you know, it's important. It's going to be mentioned in the class. I'm pretty sure. So let's see if it let's see if a0 is gonna be 40. Wait. Okay. Size of the array is 10. As you can see, where is a0? A0 is 28, which means it's 40. And then we jump back to our to the place we jumped from, which is register R4004, which is this one, which is like terminate the program. Cool. So now we learned how to multiply, how to create an array. Now let's start with loops. Oh yeah, sorry, before we start with loops, I forgot to say they're 40, and this means they're 40 bytes, and 40 bytes are equal to 10 words, just to make sure that I didn't miss anything. Okay, next. I didn't create the array yet, but like I told you how we're gonna create the array. We basically are going to, we have now the bytes in A0, so we don't need to load 40 to A0 because A0 is already 40, right? All we need to now to do is load immediate v09 syscall, and now, oops, go here, yeah, and now we created an array. I'm just gonna write arrays address. I'm just gonna write v0 equals arrays address. Cool. Now we created the array, and let's say I don't like the array's address to be in v0 because I'm gonna use v0 in storing and retrieving data, or like loading data. So I'm moving v0, no, sorry, a0, yeah, no, not a0, t0, t1. Did I use t0? Yeah, I did use t0. I used t0. Wait, I don't need t0 anymore, because as you can see, I just needed t0 for multiplication. Now I have allocated the array. I can change t0, and I'm gonna change t0. I'm gonna make t0 my own array, which is yeah, it's the array that I created, now it's v0. So this basically means move v0 to t0, and now I can say that the array is created and it's in t0. Wait, this is how to create an array. Well, this is everything I want. I don't want a t0 anymore. Why though? Because as I said earlier, this is the end of the function. This is create an array, right? So we create an array and we want to return it. And basically, as we said earlier, v stands for expression, evaluation, and results of a function. Create an array is a function, and the result is going to be in v0. So therefore, after I'm done with this, I just want to jump back to the main memory, to the main function. So as soon as I'm done with this, this means jump back. Now I have the array in v0 and I want to give it to one of the saved registers, and let's say s0. Oh my god, I totally forgot. It's very important. Have you ever made an array without knowing how many elements, or like how many elements you have in it? No? So basically you need to know. And therefore I am going to, so basically here we get the size, right? Here we ask for the size, and here um, we get the input from the user, and let's say I said it's gonna be 10, right? So I want to store this 10 and I'm gonna move it from v0, v1, v0. v1 is equal to 10 now. Why though? Because I have v1 and I have v0. So v0 is gonna return the address of the array, which is the array itself, and v1 is gonna return the size of the array, which is 10, right? It's very important, it's very crucial to know the address and to know how many elements you have in the address. I said 10, so basically I have 10 elements. And v1 is going to be used in loops, right? How do we make a for loop? We basically write I equals 0, and then we say I less than the number of size of array, and therefore we loop till the last element of the array, and therefore we go all over the elements. Same thing, we need to know how many elements we have in order to loop over them. So now I'm gonna move s0 v1, sorry, move v0, no, sorry, s0 v1, and this means s0 is equal array's size. I'm gonna do the same thing, but now I'm gonna switch some stuff. Oops, delete. This is gonna be s1, and this is gonna be v0, and this means s1 equals array's address. Okay, so basically all I have done after I moved the important stuff to saved registers s0 and s1, we said that s0 is array size and s1 is array's address. Now I want to start putting or storing elements in the array, which is uh, in s1, sorry. So basically I want to jump to a function that stores array, right? And in order to store to the function, I need to have a parameters and how to create it. Like first of all, we created an array, right? I now want to use the size of the array, and I want to use the address of the array to store the element in it. So basically I just moved all of these to the arguments, which is a0 and a1, and then I jump to store array, and here is my store array. As you can see, all I have done here is I moved the argument to the registers t0 and t1 because they are temporaries. As soon as I'm done with this function, I need to reset them and delete them in order to use them for the future again. Now, if we go upstairs, as you can see, I just made a function that asks the user to insert an element to store it in the array. I'm gonna print it and come back to you guys. Okay, as you can see, I have printed the message insert, which means write the element that you want to store in the array. And now we're taking a number from the user. But it's not viable. We need to have a loop in order to make it run 10 times in order to store all the 10 empty places that we have in the array, right? But before this, I need to store the element in the array. as far as I know, all I have done is I just asked the user to give me an input, and now he gave me an input, and as we know, it's stored in v0. So all I'm gonna write right now is store word. Where is the array? Where is the size? Where is the array's address? The array address is in T1. So basically, I'm gonna store word, which means I'm gonna store what's inside v0. Okay, I stored what's inside v0 to one of the registers, and basically I'm just gonna store it to t1, and let's say 0 t1. So 0 is the pointer. 0 can be 0, it can be 4, it can be 8. So 0 stands for the first element, 4 stands for the second element, 8 stands for the third element, and so on. But because it's not viable to write this, like many times, and then we have here 0, we have here 4, we have here 4, we have here 8, and then we have here c. It's not viable. So basically I'm just gonna put it in a loop, right, where every time I go one to the next element, to the next empty element in the array, and I store a new value in it. So I'm just gonna delete this now, and this means store the element in the array, right? And then notice this is a big brain move. After we do this, we're just gonna write add I t1 4. What does this mean is make the pointer of the array. So we know the array address start at t1, and where is t1 right now? Oh yeah, I didn't run the program, so now it doesn't know what is t1. I need to execute it first, right? Oh yeah, that was a comment, my bad. I need to execute it first, and then I need to run it, and while I'm running it, it's gonna tell us what is the address of t1, but this doesn't concern us right now. So basically t1 is the beginning of the array. Let me give you an example in a better way. Okay, so wait, let me do it in a better way. Right now t0 is the array itself, right? But it points at just the beginning element of the array, which is 5. Let's say this is like an implemented array, right? It's 5, right? And when I say t0 is equal to t0 plus 4, when I increment t0 with 4 elements, it's just gonna move from 5, let me change it to Magenta, it's 5 to 10. And then if I add t0 with another 4, it's just gonna move from 10 to 15. I hope you got the idea, because this is what am I doing here in Mars program. All I'm doing is I store the value of v0, which is the input from the user. I store it to the array, right? T1 is the array's address, and then I increment T1 with 4, which means go to the next element of the array. So basically T1 is pointer of the array. Remember, you cannot increment T1 unless you stored your array somewhere else in order to come back from where you from what you have been implementing. As you can see, I stored my array in S0, array address in S1. So S1 is also pointing to the first element as T0 here, like T1 here is pointing also to the first element. But as soon as I'm doing this, this is also gonna be S1, sorry, but now T1 is going to be in 10, while S0 is going to be in 5, and S1, I'm not gonna move it. S1 just there in order to save the header of the array. Okay, so basically this is how we store, wait, that's wrong color. Yep, dark green. Basically this is how we store values to the array, loops left, and how to load values from the array. Okay, now I move the pointer. This was the first time I accessed the first element of the array. So basically I can say this is the first loop, right? So since I have a free register, which is called, I used T0, I used T1, I didn't use T2. So basically I'm just gonna write add I T2, T2, 1, and this means T2 is the counter of the array, the counter of the array size. Why though? Because as soon as I do this, I'm gonna go here and then I'm gonna write the following: branch not equal t2, and what is the size of the array? Array size is in t0, and then jump to loop. Where is the loop? I'm gonna put it here. Why? Because if you want to have a loop, are you going to move everything you started? Like, are you going to 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 change the parameters with them? So basically, I just move the parameters from A0 and A1 to T0 and T1, right? I don't need to do this every time. Maybe T0 and T1 change in the following loop. So this is gonna destroy everything I'm planning to do, right? As you can see, I as you can see, A1 is moved to T1 and T1 is the beginning of the array address, but every time here I increment T1 with 4. So basically it's just like if I put the loop here, right? If I put the loop here, which is if I put the loop here, basically I'm going to start from the first element of the array address, the first element of the array, and then I'm gonna increment 4, and then I'm gonna check T2, it's not equal to T0, right? Let's say T2 now is 1, right? But T0 is 10 because I said the size of my array is 10. So 1 is not equal to 10. This is true. So jump to loop. Now we go loop and then we move T1 to the first element of the address. Remember, we incremented T1 with 4 in order to go to the second element in order to put the new value in it. But what we're doing now, we're destroying what we have been doing and we're going back to the first step and then restoring the new element to the first element, which we already gave a value to. So now we're just gonna loop for only the first value. So make sure you know where you put your loops or labels, right? So I'm gonna restore it here. So basically, everything inside this code is gonna be executed till T2 is equal to T0. Is T2 equal to 10 and T0 equal to 10? Yes, they are equal, right? But here it's called branch not equal. So if they're equal, it's gonna skip and it's gonna go here. And this is how to make loop. I hope I made it clear. Since I'm just storing elements in the array, I don't need to return anything. Therefore, all I need to do is just jump RA, which means jump register RA, and we're just gonna go back to the code which should be existing here. Of course, there is like a rest of the code is gonna be here. I'm gonna write jump on link, not store array. What did we say we want? We want to store array and we want to show the elements of the array, which calls load array, which means load the elements of the array to registers, right? And this means jump to load array label. Make sure to have comments. It's very easy for you to understand your code when you leave it like for days and come back to it to fix some stuff or to show it to the TA so you know what you're doing. He knows that you understand your code. You have nice and neat comments. But remember, before we jump back to any function, before we go to function, before we leave a function, we need to reset all our T registers. So all you have to do, load immediate T0 0, right? Because this is the end of the loop. This won't happen unless the condition is met. T2 is equal to T1. So basically T2 and T1 should be equal, which means they should be equal to 10. So this loop is gonna happen like 10 times. Now which registers I used? I used T0, T1, T2. I didn't use T3. So all I'm gonna do, I'm just gonna load immediate T0, load immediate T0, load immediate T0, change this to 1 and this change this to 2. And this means reset T0, and same for the following registers. So now loops is done. Now we just need to load values from the array. I made a small mistake. In order to load from array, you need to have the array size in order to make the loop, and you need to have the array address in order to take the elements from the address. And therefore, I need to copy this line and put it between these two functions. So these are my parameters for load array. Now I can also copy these lines because, as I said, it's not important to reset like the registers, but it's better to reset the registers as soon as you're done with the function, so like your code doesn't become messy and you start using the rest of the registers. So you say T0 and T1 and T2 are used for store array, let me use T3, T4, T5 for load array. What if you have like 50 functions or like 10 functions? You're not having these much registers to use. So basically, as soon as you finish using a register, as soon as you're finished using a function, please reset all the registers you have used, and specifically the T registers. Okay, now I'm uh, just gonna do this, which means move the elements that I'm gonna need. And now we need to load from an array. Yes. And how to load, you want to print the result, sorry, the element of the array, right? So basically, how to print an integer. You print an integer by, we said earlier, you load the address of a to a0, and then you load immediate v0 to 4, and then you syscall, right? But since we have the element inside uh, an array, we don't need to load word. All we need to do, we don't need to load address. All we need to do is load word. So load word, and then you take it from the array. Where is the array? At this case, my array is in T1. Where do you want to store it? I want to store it in A0, right? And then I'm gonna write 0 T1, and this means fetch the element from the array, which is T0, and store it to A0. You can just say T0, 0. T0 is the array, and 0 is the place that's T0 at the moment, equal to A0. After this, you need to write load immediate v0 for syscall, and this basically, let's just try it. Size of the array, let's say 1. Insert the element 2. Oops, I have a mistake. So I traced my code and I understood the mistake. So basically, after I move v1 and v0, which are what I returned from create array to s0 and s1, I also, because they're the same thing, I move them to a1, a0 and a1, right? Like nothing changed, right? I just move v1 to s0 and a1, and v0 to s1 and a1. And then I enter to store array, and when you enter to store array, there are some stuff that changed. As you can see, v0, it have been called many times. So v1 didn't change, but v0 actually changed, and therefore it 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 destroyed my program, because I didn't notice that v0 have been used and now it changed. So basically, in order to fix this problem, I'm gonna use these s registers. See how, like, it is very important. See how it saved my life to store it in s registers, or like saved registers. Yes. So array size is 0, sorry, is 0. Oops. And oh, and we're gonna do the same here. Oh, this is s1. We're gonna do the same here, s0, and this is s1, and I think it should be fixed. Another mistake I did is, after I loaded the integer to a0, I said load immediate v04. And remember, load immediate 04 is to print. Is to what? Is to print a string. But a0 contained an integer, therefore a problem happened. So we need to change this 4 to 1, and now we're gonna print an integer. Let's try it again. Size the array 1, insert the element 20, and now it printed 20. As you can see, it loaded, uh, and it loaded and it loaded it, and then we printed in v0. This is actually print the array element after loading it from the array. Cool. Now we need to create the loop. So I'm gonna create the loop in a bit and come to you guys. I don't need to explain it one more time, but I will explain it as soon as I'm done with it. Alright, I'm done writing the code. Let me explain it right now. Okay, so basically I made the loop. So as soon as we start, like, move our argument to registers, I load the elements from T1 to A0 immediately, so I print them, right? Print the arrays element after loading it. So it's like saving steps, and instead of loading it to another register and then moving what's inside that register to A0. I just move it to A0 and I just load it to A0 and then I print it by loading immediate V01. And then I increment my array T1 with 4 because as I said earlier, in order to move from the first element to the second element or from one element to another element, you increment or decrement by 4, right? And then I incremented my counter by 1, and here this is like a big brain move by me. It is very easy and simple. So basically here I check if T2 is equal to T0. So if T2 is equal to 10 and T0 is equal to 10, we're immediately just going to jump to last loop. If not, let's say T0 is 1, T2 is 1 and T0 is 10, right? So we're gonna here and then we're gonna print this thing. And this is basically a comma I just wrote up here, and it's just space, comma, space. So I did this in order to, when I have like 5 elements, I just need 4 commas, right? So I don't need to print the last comma because I mean this is a logical thing. So it jumps to last loop and last loop is here, and then it just says branch not equal T2 T0 load loop, and this means if T2 is 10 and T0 is 10, they're equal, right? But this means branch not equal, which means they shouldn't be equal in order to jump to this loop. But since they're equal, it's just gonna end. I just forgot to reset the registers I used, and I forgot to jump back to where I started. So basically, since I used the same register, I'm just gonna copy this. I'm pretty sure this time that it won't make mistakes. It won't make problem. And now I jump back after I reset everything. I don't need to return everything. I just wanna print the result. What's inside the array, and then I just wanna jump back. So when I jump back from load array, it just the program ends and now we're done. I actually don't need this anyway because like now I'm done. Like the main function just finished the program. Let's run it. So size of array, as I said earlier, let's make it 7. Insert element 0, 1, 2, 3, 4, 5, 6. And as you can see, I have 1, 2, 3, 4, 5, 6, 7 elements. They're from 0 to 6, and this is literally what I wrote, as you can see. 0, 1, 2, 3, 4, 5, 6. And how many commas? 1, 2, 3, 4, 5, 6. And the 7th comma should be here, but because my if statement that I made in the load array function, load array function, because of this of this line, because of this line, this comma won't be printed, and this is if statement for you. This is the loop, and this is how to load. And now we're basically, wow, now we're basically done with everything. Thank you so much. I'm sorry that this video is over 50 minutes, but next videos are gonna be so short. Hopefully they won't be more than 12 minutes or 15 minutes, to be honest, and they will be very important. So make sure you guys watch them.